Hi everybody, we are starting a brand new topic. We're going to start solving quadratic equations. So this is in a new section and a new topic, but if look at the do now, the first question I ask, I say, if I told you that the product, okay, so I want you to think about that word product. Hopefully you are all thinking it means to multiply or the answer when you multiply. So if I told you that the product of two numbers is zero, what could you tell me about the two numbers? Anything. Can you think of something you could tell me about the two numbers if the product of two of the numbers is zero? Okay, well, hopefully you're saying at least one of the numbers maybe both of the numbers have to be zero. Right? Because when you multiply a number by zero, you get zero. And if they were both zero, right? So if I literally did 5 times 0, I would get 0. 0 times 0 would give me 0. 0 times 3 would give me 0. So at least one of the numbers, maybe both, would have to be 0. Okay, so we're going to be talking about the zero product property. If an expression is equal to 0, think about what we just said. We know that at least one factor must be equal to 0. So if I give you two factors, x minus 3 and x plus 10 equals 0, this is how you are going to solve. That looks like it was factored already. So what you are going to do is take each factor, and I set up what I call what looks like a T, right? Doesn't that look like the letter T? Take each factor, x minus 3 and x plus 10, forgot my 0, and set them each equal to 0. Because I know at least one of them has to be 0. Now this is just two little mini equations. If I wanted to solve this equation on the left-hand side for x, I would just add 3 to both sides. Does everybody see that? The inverse of subtraction is to add. And on this side, I would minus 10 from both sides. So on the left-hand side, x would equal, this would be gone, it'd be 0, 3. And on the right side, these would equal 0, so x would equal negative 10. So I want you to take note of something. Notice the factor inside. Here's the factor. Okay? These are the factors. Inside the parenthesis, you had a minus 3. But when you get down here, which we call the solutions, the signs change. This was x minus 3 up top. It wound up being x equals positive 3. And when you saw x plus 10 in parentheses, you see x equals negative 10 as your solution. So take note, very, very important, that your signs change from your factors to your solutions. Make a note of that. Signs change from factors to solutions. Okay? So I give you the steps for solving. You're going to get your quadratic into standard form. We haven't talked about that word, those words, standard form. It just means your equation is equal to 0. You're then going to factor. Now remember, we have different types of factoring methods. You're going to look for GCF. If not, the difference of two squares. If not, grouping. If it's not grouping, it could be just a basic trinomial. That's where a equals 1. Or you could have a trinomial where a is not equal to 1, which was what we called split the middle. Okay, so you have 5 different factoring methods to choose from. Okay, so when you get your answers, these solutions, they're either called roots or solutions. So everybody take a look at number 1. We're going to factor x squared minus 3x plus 2. The first thing you're going to look for, do they have a common factor? Anything that all 3 of them have? You should say no. No GCF. Is that the difference of 2 perfect squares? No way. First of all, there's a plus. There's more than 2 terms. There's 3 terms. It can't be the difference of 2 squares. 3 and 2 are not even perfect squares. It can't be grouping because there's only 3 terms. I know you see the equals 0, but the terms are x squared minus 3x and 2. This is a basic trinomial. And A equals 1. Where's my 1? Right there. It's like you don't even see it, but that's technically a 1. Here's where you don't have to do anything except for pull off 2 to the side. And ask yourself what multiplies to 2 and adds to negative 3. And that would be negative 2 and negative 1. Your sign should be the same. They multiply to a positive and they add to a negative. So watch, I open up my 2 parentheses and I do an x minus 2 in one of them and an x minus 1 in the other. But you can't forget that equals 0. And now you have what we started with up top. You're going to take your 2 little parentheses and you're going to set up a t. Okay? And you're going to take x minus 2 and x minus 1 and set them equal to 0. And again, you don't have to show this, but I'm going to show what's going to happen. Technically, I'm going to add 2 to both sides and add 1 to both sides because I'm going to get x, that's 0. 0 plus 2 is 2. And here that's 0, x equals 1. So here you could do it like that. You could show it as a solution set, 1 and 2. You could show it as 2 and 1. The order doesn't matter because they're both x values, but those are your solutions or roots. Okay? Okay, so everybody take a look at number 2. When you look at number 2, do you see a GCF? Everybody should be saying, yes, there is a GCF, there's a GCF. The GCF is not only 2, they both have at least an x in common, so your GCF is 2x. Look at where my GCF goes, in the front. I have to have that as part of my answer. Now, I'm going to divide each of those terms by 2x to help me figure out what's left in parentheses. Okay, when I divide, I get x plus 7. So one term is 2x, the other term is x plus 7. That's going to make up my t. I'm going to just move this just a little. Okay, so now we're going to take 2x and set it equal to 0. We're going to take x plus 7 and set it equal to 0. Just like you solved those other ones, here I'm going to show to get x by itself, I can't add or subtract. I have to divide 2 by both sides. That would give me x equals 0. It's one of your solutions. On the other side, I would minus 7 from both sides. So here I get x equals negative 7. So you have 2 solutions. I don't like that one. 0 and negative 7. It doesn't matter if a kid wrote negative 7 and 0. Again, the order of these don't matter because they're both x values. If it was an x and a y, it would be in parentheses. These are not x's and y's. They're not points. They are both x values. Okay, let's try another. Tell me about x squared minus 81. There's no GCF. They don't both have an x in common. Is it the difference, okay, there's a minus, of 2 perfect squares? Is x squared a perfect square? Yes. Is 81 a perfect square? Yes. This is the difference of 2 squares. That means automatically open up 2 sets of parentheses. Don't forget your equals 0. The square root of x squared is x. The square root of 81 is 9. 1 minus 1 plus, order doesn't matter. The term matters, like you need the x first, the 9 in the back, but where you put the minus and the plus doesn't matter. Your first parentheses could have a plus or a minus. All right, you're ready to go. Set up your t. Take x minus 9, x plus 9 equals 0. Again, when you do the inverse operation to move to the other side, I get x equals positive 9. Makes sense. If inside my factor was negative 9, my solution should be x equals 9. And here, on this side, 0 minus 9 will be negative 9. Inside my factor was positive 9, and it became negative 9. So your solution is, you could say 9 and negative 9. Some people like to just write it plus and minus 9. Either one would be acceptable. Okay. Take a look at number 4. Okay. Is there a GCF between 3, 10, and 7? No. It can't be the difference of 2 squares. There's 3 terms. Now, getting to grouping, nope, there's only 3 terms. You would need 4 terms for grouping. This is a trinomial, but look, A is 3. So this is A split the middle. This is that extra step that I know a lot of you are struggling with. You have to take 3 and multiply it by 7. Because if you just pulled 7 off to the side, you'd make yourself crazy listing numbers that multiply to 7. They would never add to 10. But what number should come off to the side? 21. What numbers multiply to 21 and add to 10? Well, 3 and 7. So here's why I call this split the middle. I keep my first term, I keep my last term, and my equals 0. And I'm going to split 10x, not into 3 and 7. These are the numbers you use, but it becomes 3x and 7x. A lot of you are forgetting the x's in the middle. And look what it turns into, grouping. Group. I purposely put the 3 with the 3 and the 7 with the 7. It makes life easier. The GCF of the first two is 3x. Okay, so I'm going to divide each of these by that GCF, and the 3's divide out. I get x plus 1. Anything divided by itself is 1. The GCF between 7x and 7 is 7. Positive has to come down. Divide them both by 7. When I divide 7x by 7, I get x plus 1. Don't forget equals 0. Don't stop there. That's not your answer. That just helps you see your 2 factors. One of them is 3x plus 7. The other is x plus 1. Now you have your 2 numbers, your 2 factors to set up your t. Now be careful with this guy. 3x plus 7 equals 0. X plus 1 equals 0. This is the easy one. I'll do it quick. Obviously, I made a mistake. X equals negative 1. But on this side, not only do you have to minus 7 from both sides, so 3x equals negative 7, you're now going to divide by 3. So x equals this number, negative 7/3. It becomes a fraction. So notice when you have this coefficient in front, you wind up getting a fraction. Your answers or solutions should be, your solutions are what we call these, or roots. Here are negative 7/3 and negative 1. Okay, I'm going to do these last 2. In number 4, number 5, there's no GCF. This is the difference of 2 squares. Open up 2 sets of parentheses. You're really taking the square root of both. It's minus. The square root of 4x squared is 2x. One's a minus, one's a plus. The square root of 9 is 3. Okay. Set up your t. Take 2x minus 3 equals 0, and 2x plus 3 equals 0. Do your opposite. So here I'm going to add 3 to both sides. Here I'm going to minus 3 to both sides. So that'll help me get to my next step. Gone. 2x equals 3. Gone. 2x equals negative 3. And in both cases, I have to now divide by 2. So now I get here on this side, the 2's divide out, x equals, leave it, 3 halves. If you really want to write 1.5, that's fine. And here x equals negative 3 halves. But a lot of the time you are going to want to see them as improper fractions. Again, you could say plus and minus 3 halves. I know a lot of kids will just want to write it as negative 3 halves and positive 3 halves. That's fine. Okay? As long as you have a terminating decimal, you could also write it as a decimal. Okay, last one. In number 6, immediately I'm going to look for a GCF. No, they don't all have an X. They don't all have a number in common. No GCF. It can't be the difference of 2 squares. There's 3 terms. It can't be grouping because there's only 3 terms. It's clearly a trinomial. It's got to be a trinomial. And this trinomial is where a equals 1, which means you don't have to multiply anything because technically you could multiply, but 1 times negative 32 is just negative 32. So you're asking yourself what multiplies to negative 32 and adds to 4? 8 and negative 4. X plus 8, x minus 4. It's got to be that. No other numbers. I mean, you could say negative 16 and 2, but they'll never add to 4. You could say, what else goes into 32? That's it, right? 5, 6, nothing else goes in. So that's it. It's got to be 8 and negative 4. Set up your T. Take x plus 8, x minus 4 equal to 0. Remember, when you minus 8, here you add 4 to both sides. And again, you don't really technically have to show me that step. It's good for you guys right now to show it. X equals negative 8. That makes sense. If it was plus 8 as a factor, the sign switches. Notice, sign changes if you're doing it right. And here, this was a negative 4 up top, but when I add 4 to both sides, x is positive 4. So your solutions or roots are negative 8 and 4. All right, guys, that's it. See how this goes? I'm going to give you a practice.